Hey guys, today have missed school because I've got to go get some baby stuff done with the doctor, so nothing to be alarmed, just one of those times I got to be out. So today we're going to do X and Y intercepts without me, but with me, so maybe I'm kind of here in spirit or something. I don't know. So we're going to talk about X and Y intercepts. Yesterday we talked about slope. Our last class we talked about slope, so today we're going to get into more of the intercepts. We're still going to use slope, so the first thing we're going to do is review how do we find slopes from a couple of points. So if you remember, the way we find slopes from two coordinates is we use the formula m equals delta y to delta x, which is the difference of the y's, or y sub 2 minus y sub 1, divided by x sub 2 minus x sub 1. Alright, now I'm going to look for my second y value. My second y value is 5, so I've got 5 minus, and then whatever my first y value, which was, it's 0. So I have 5 minus 0 as my numerator. My denominator is 3 minus, it is not 3 minus 2. If you have 3 minus 2, that's incorrect. It's not 3 minus 2, it's 3 minus negative 2. 3 minus negative 2, which is 5, to 3 plus 2, which is 5, and that is 1. So this slope is 1. The next thing we're going to do is find the slope from a table. So I will go ahead and give you the table. The table I'm going to give you is -4, 0, 12. These are the x values. The y values are 2, 3, and 6. Alright, and then go ahead and pause this video and go ahead and try to find the slope of this table on your own. So now you've finished trying to find the slopes. Now we're going to put it to action. M equals, it's delta y to delta x. The delta y is 2 to 3, which is positive 1. And the delta x is -4 to 0, which is positive 4. Alright, so the rate of change between these two coordinates is 1 to 4, or 1/4. So then I'm going to try it again just to make sure this is linear. Delta y to delta x. Delta y is 3 to 6, that's positive 3. Delta x is 0 to 12, that's positive 12. 3 to 12 is 1 to 4, so my slope is 1 to 4. M equals 1 to 4. Okay, next thing is finding slope of a graph. So in order to find the slope of the graph, what we do first is we plot two good points. These 2 points will enable us to find the slope. So the 2 points I'm going to use are this point, and this is real small on my part, so I can't see it very well. And choose this point right here. Alright, so that's the 2 points. Then the second thing I'm going to do is I'm going to find the change of the y's and the change in the x, and we found out that the change in the y is just the vertical change, or we call that the rise. The change in the x is the run. I'll give you a minute or so to find the rise and run, so go ahead and pause this video, find the rise and run between your points or these points if that's what you plot. So if you do the rise and the run, Okay, you get a vertical rise, and then you get a horizontal run. Okay, your vertical rise is 1, 2, 3, 4, 5, 6. So that is 6, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. But this is upwards and this is left, so this is going to be negative 9. So that's negative 9. 6 to negative 9 is 2 to negative 3, or m equals negative 2/3. So your slope is negative 2/3. Another way that you can tell your slope is negative is because this line is going down from left to right. This line moves downward from left to right. Last thing we'll do is look here. Mr. Mize bought 10 cards for $15 and 17 cards for $22. What is the slope? Again, we are going to use delta y to delta x. The difficulty, if anything, is being able to figure out what is y and what is x. So y is your dependent variable. Your dependent variable is dollars. So you have to find the difference in the dollars. Your independent variable is the number of cards. Okay, so the dependent variable dollars, the difference in the dollars, 10 cards for 15, 17 cards for 22. The difference in that is $7. $7 difference between 15 and 22. The difference in the cards is 10 to 17, which is 7. Alright, so this is $1 per card after some kind of initial value. Okay. Another way to do this is to create a table. Still have to know what is X and what is Y. So if 10 cards cost $15, I could write it like this. 17 cards cost $22. And then when I find the rate of change, I do delta Y, which is 7, delta X, which is also 7, and 7 to 7 is 1. So either way, we get a slope of 1, or 1 to 1. So go ahead and stop it here if anyone has any questions. So that was the review. Now we're going to move on to the X and Y-intercepts, which is the point of the lesson today. So we're going to start off with a couple of definitions, then we're going to keep going back to this. Alright, the X-intercept, there's a couple of ways we can think about this, but the X-intercept is it's the point where the line intersects the x-axis. Alright, so the x-intercept is the point, it's the place where the line intersects the x-axis. This can be a line, this can be a circle, this can be a curve. Anything that intersects the x-axis, that's called the x-intercept. And the y-intercept is the point where the line or the graph intersects the y-axis. We're going to be dealing with lines a lot, so I am going to write line there. That will change later on this year. Alright, so go ahead and pause this video if you need time to write that. Alright, so here's what I know about identifying from a graph the x-intercept. Alright, the x-intercept of this graph is the point where the line intersects the x-axis. Well, that point is right here, and that point is 3, 0. That point's 3, 0. The y-intercept of the graph is right here. That point is 0, -6. Now, right here, what we've kind of just discovered is something else that could also be written in the definition, and here's what it is. The x-intercept will always, not sometimes, will always have a y value of 0. Always. For the x-intercept, the y value will be 0. The y value will be 0, just like that. Therefore, the y-intercept will what? Well, every y-intercept will have an x value of 0. Not sometimes, not occasionally, not most of the time, always. Every y-intercept will have an x value of 0. That's what makes it a y-intercept. This is what makes an x-intercept. So this is going to be how we know that intercepts are intercepts. If the y value is 0, then this will be an x-intercept. If the x value is 0, this will be a y-intercept. You don't necessarily have to memorize this. You'll just keep doing this. We'll keep doing it. We'll keep doing it. So let's go ahead and keep going. The next part, we're going to draw a line if the intercepts are -5, 0, and 2, 0. This is going to be pretty easy. So basically what I'm going to ask you to do is plot these 2 points. Go ahead and take about 10 seconds and plot -5, 0, and 2, 0. Again, you'll notice -5, 0 because y is 0. This is going to be an x-intercept. And 2, 0 because, these are, this is a mistake. So let's go ahead and change this to 0, 2. Just notice that. Alright, this is -5, 0, which is going to be an x-intercept. This is 0, 2, which will be a y-intercept. Alright, so go ahead and plot those 2 points.